Your fearless leader, Will the Chill. Some of you may know me by my legal name, Will Braswell. You may remember me from such Perl projects as RPerl, the optimizing compiler, and the Perl Town Hall, and the Perl Community Roadmap, or how to put Perl back on top. Today, we are going to talk about another part, as we have been, of our Perl Community Roadmap. So, if you would like to follow along, you can go ahead and point your web browser to perlcommunity.org and find the page for performance. Now, if you're looking at the front page of the website, you'll want to scroll down to where it says performance and then click learn more. The URL is perlcommunity.org/performance.html. So, we have a little quote here at the top. Depending on how many times you reload the page, you'll get a little fortune cookie quote from St. Larry Wall, our founder of the Perl language and community. And today's quote is, quote, "It is, of course, written in Perl. Translation to C is left as an exercise to the reader." Unquote. And if you reload the page a few times, you'll see some other interesting quotes from St. Larry in reference to speed and performance. Another is, quote, "Perl has had a long tradition of working around compilers." And, well, I think Perl should run faster than C. There you have it. St. Larry said it himself. So, what is performance and why is it important? And why are we talking about it? Oh, and hello everyone who's joining. My dear Benny and Faraz and Randall, thank you everyone for joining us today. So Benny has posted the link for today's Perl Town Hall. Hello Max, glad you could join us, my new friend. As they say, brilliant! So there you go, just a little joke for you there, Max. You can point your browsers to perlcommunity.org/performance.html. If you would like to learn about the other previous parts of the Perl Community Roadmap, you can rewind in time and go back to the other last week's and previous week's editions of the Perl Town Hall. Or, if you'd like to find out about the parts that are after the performance page, you can activate your time machine and jump forward several weeks. Or just wait and then watch the video when it comes out. So, again, performance. St. Larry says, "I think Perl should run faster than C." Let's just unpack that for a minute, just because it's such a profound statement. For those of you who have not watched our previous segments or are not familiar with the Perl Community Roadmap, there is an idea that is called the legacy language, the concept of being a legacy language. And this is under the industry section of the Perl Community Roadmap. So you can see that in our second video or online under the industry page. Now, a legacy language essentially means that the language has entered such widespread usage and so many worldwide mission-critical systems are written in said language that the language can no longer be deleted or replaced, essentially permanently for the foreseeable future of humanity. And we already know that we have a few obvious legacy languages, and the most obvious of the few legacy languages that exist is C. The third letter of the alphabet and the world's most critically important programming language. That's right. Even more critically important than our beloved Perl. And why is that? Well, everything that's important is written in C. Perl is written in C, C89 to be specific. Linux is written in C. Those other proprietary operating systems are generally written in C. Anything that you need to run fast is written in C. Other languages are written in C. As I said, Perl and Python and Java and all of these other competitive languages tend to be written in C. And even C itself is at this point written in C. So that means it's a bootstrapping language that can compile itself. And we should be a little bit more clear that C is a specification that's like a international standards document that you can use to implement a C compiler, which is how you actually compile and run applications or other software written in C. And so when I say C or something is written in C, I'm usually referring to the GNU C compiler collection, GCC. And that's what we use for all of our development, and that's what most Perl people use to compile Perl itself and everything else. So to be faster than C is no small feat. In fact, it seems to be perhaps impossible on the surface because C is what everything else is written in. C is the fastest language in general, and the compilers that exist for C, which include the GNU compiler that I mentioned, the Clang compiler, and all the other proprietary compilers made by operating system or computer hardware manufacturers, these are all highly optimized compilers. And what that means is that more people have spent more time trying to optimize those compilers than any other compilers in the world. So the more man hours you have and the more smart people you have to optimize a compiler for a language, then the faster, in theory, that language will go. And that's is due to the age of C. C is one of the oldest languages still in common usage, and it is that time that has allowed the extended manual optimization period so that the C compiler is the fastest in the world. Now, the interesting thing about that is, again, if we just take the GNU C compiler only, because there are many others, and we're not going to delve into the differences between C compilers. That is not our goal for today in any way. But just with the GNU C compiler, it's actually now called the GNU Compiler Collection. It's still the same acronym, GCC, but it was the GNU C compiler, and now it's the GNU Compiler Collection. And that's because GCC can actually compile a few different languages now. It can compile, of course, C, but it can also compile C's older brother, so to speak, or older sister language, depending on your gender preference, which is C++. And for example, we use the advanced features of the new versions of C++ in order to implement all the core components of the RPerl optimizing compiler. So C++ is also very important, and it uses the same compiler. So you would type like GCC space and then the name of your C program in order to compile something in C, or you would again just type the same command, GCC space and then the name of your C++ program, and it would work the same way. And the interesting thing is that also There are some other old languages that are kind of still in common usage. Pascal, the often maligned COBOL, and then one that I'm sure many have heard of called Fortran. And the interesting thing is that Fortran is also built into the GCC compiler. So really GCC is at least 3 languages combined into one compiler. And that means that pretty much you can actually write the same program in all 3 of those languages and compile it with the same compiler, and it will be about the same speed. Now, depending on how much effort has gone into optimizing the C subsystem of GCC versus the C++ subsystem and the Fortran subsystem, there may be different parts of each language that are slightly more optimized than the other parts, but it's safe to assume that they're all within a minuscule, 0.00 something % speed of one another in most cases, if you use the same sort of algorithms and code constructs that are native to each of those 3 languages. Now, what does this have to do with legacy languages and Perl running as fast as C? Well, it's pretty much safe to assume that the only real 3 legacy languages that are easily known and agreed upon by everyone are thus going to be C, C++, and Fortran. Now, you could argue about other ones, but those are really the only ones that are clear-cut. However, there is a link and a brief discussion in the industry video that you can go watch if you want to about legacy who had made a very interesting video about legacy languages. It's actually a presentation at the Perl conference in 2016. So Dr. Thomas Radcliffe had done some industry analysis and came to the very educated conclusion that Perl is also now a legacy language. And I tend to believe him. I actually took him aside and spoke to him at great length about it. As soon as he finished giving that talk, we walked right out and sat down and talked about the whole thing. And you can hear me asking 1 or 2 questions or making some comments at the end of that video as well. So I was in the audience, and that video is important because it means that Perl is something that can never go away because it's in such widespread use, which has several implications. Number 1, it means that while the demand for Perl may seem to be waning, it's really because, well, we've caused our own problems with the Perl versus Raku issues, but really the size of the pie is growing. Perl used to have like all of the pie, the slice of the pie for dynamic languages, and now there's so many other dynamic languages, and the pie is growing because so many companies want to use dynamic languages like Python or Ruby or whatever. Then the pie is growing, but there's more competition, so our slice seems to be shrinking. And we need to do things to stop our slice from shrinking too much, and all the Perl programmers starting to have a hard time finding jobs, which is already happening, and that's why the Perl community roadmap exists. But it also means that we have to be concerned about the performance of Perl. And this is obviously why I took the last many years to write the RPerl optimizing compiler. And this is the only way. There is no other way to get Perl to run as fast or faster than C. And we'll talk more about RPerl in a moment. But the general idea here is that Perl is a legacy language like C and C++ and Fortran. And so we have to start thinking about it a little bit different. And we have to have a more solid long-term plan, which again is what the Perl community roadmap is. So can Perl run faster than C? That should be the question everyone is asking themselves right now. And we're going to say hello to Stefan. Stefan says the first thing he heard upon joining is faster than C. Yes, wonderful. Stefan says, that reminds me of the last 2 weeks I got confronted with JavaScript on the server side using Node.js. I figured out that there is one scripting language which fulfills this requirement for not really speed optimized C code, and that's currently JavaScript under Node.js. So yes, JavaScript is a dynamic language in that you don't have to use data types, and it can dynamically allocate memory and other things that dynamic languages like Perl do. And usually JavaScript runs in the browser, but you can get it to run on the server side using the Node.js framework. Now, I do JavaScript programming in the browser because you have to in order to have a nice front end, but of course I always use Perl on the back end. And JavaScript is currently quite a bit more optimized than Perl is, not counting the RPerl optimizing compiler, but just talking about normal interpreted Perl versus interpreted JavaScript. Yes, JavaScript is quite a bit faster. This all started back when the browser wars really heated up, and it was Google stepping into the ring with their Chrome browser, and they wanted to have the new Web 2.0 where all of our apps are running online like Gmail and Google Docs instead of the traditional desktop-based Mail and Office suite. So they had to have a super fast implementation of JavaScript that was originally called V8. It was a virtual machine that Google hired some European company to implement for them and then embedded it in Chrome. And since then, Firefox and the Mozilla Foundation have revamped their JavaScript performance, and many other groups have as well. And then, of course, we have the new WebAssembly that is a layer that would go underneath JavaScript and allow other languages to compete on the browser, which we see with the new WebPerl and so forth. And so a shout out to Hauke X for his really neat WebPerl, which is a recompiling of the Perl 5 C89 code using Clang onto WebAssembly. And then also a shout out to Flavio Glock for his Perlito system, which can run Perl 5 code using JavaScript. So those are two very different implementations of how to get Perl running in a browser, and they both sort of relate to the JavaScript issue. Eventually JavaScript will go away and we'll be able to use Perl in the browser and the server without any headaches. Right now that's experimental, and thank you to Flavio and Hauke for that. Hello Camel for joining us. Thank you for joining us. Stefan says, it pairs almost the convenience of JavaScript with the speed of a native language. That would be a big deal in Perl, and JavaScript isn't that far away from Perl in my opinion. Well, yes, as I just said, Perlito is a translator from, or a platform from which to run, using some amount of translation, Perl code in JavaScript. So obviously they do have enough in common to be able to do that. and if you use the RPerl optimizing compiler, then you have the speed of totally native machine code, or, you know, as best as you can get with a compiled language, and we'll talk more about that again in a moment. So, Camel says, Perl can't be gone away. Don't forget that Windows system is using it. I have no idea what you're talking about there, but okay. As far as I know, there is no Microsoft software that is dependent upon Perl. In order to run Perl in Windows, you actually have to go through quite a few gyrations and jumping through hoops and doing things that are not meant to happen really in Windows, like recompiling Perl and using Strawberry, or getting a Unix-like environment using Cygwin, or just running the whole thing emulated inside of a virtual machine. But there is a lot of Linux software that is based on Perl, obviously. So that would be, I think, the primary reason why Perl can't go away. A lot of server software that is in use all over the world is written in Perl. And we did mention the server-side applications during our application video, which was last week. So Stefan also says, the thing to point out is that you can do one-to-one, write the same code under Node.js, and in many cases it runs faster than C doing the same out of the box. Well, I have never done testing of Node.js versus C, but I can't imagine how Node.js could be faster than C unless you're doing some weird stuff that C is not meant to do and that only dynamic languages can do at a reasonable speed. But if your algorithm does not require dynamic behavior, which it shouldn't, because most algorithms should be able to operate in a static manner, then one would assume C will pretty much always be the fastest. So Stefan says, yes, you can tweak your C code until it's faster, but for a scripting language with one-to-one code, it's impressive. Yes, well, I think the whole idea behind scripting or dynamic languages is that it's very easy to write the code quickly because you don't have to worry about things like memory management or, you know, data structures and complicated stuff like you have to do often manually in C. But again, if you are a professional C programmer and you already know how to do all that stuff just as part of your day job, then yeah, there would be no competition. If you wrote your code in an interpreted language, even a very optimized interpreted languages, then it would not be as fast as a fully static compiled language. Now, I know there are probably ways to get JavaScript compiled into C. I don't know what any of those mechanisms might be because I have no need to do that myself. Node may do part of that. I don't know. But if you could compile your JavaScript into C, then you could get it to run at the speed of C. And that is what we do with the RPerl optimizing compiler, which we will talk about here in just a moment, as soon as I get done reading everybody's comments. Yes, Stefan, I understand that it is both the difficulty of writing the code and the speed at which it can run with a minimal amount of difficulty. So again, if you're a really experienced C programmer, I can't imagine that you would write in anything other than C. And that's what pretty much all operating system programmers and video game programmers and system critical, mission critical, real-time system programming, it's pretty much in C. So, moving on, let's talk about the RPerl optimizing compiler. And we won't spend too much time on this because everybody knows that RPerl is the Perl compiler. So, essentially what you do is you feed as the input your low magic Perl code, and it will generate as the output a type of high-speed C++ code. And then of course we use GCC to generate the final binary executable files. There's no need for me to rewrite GCC, and it would be foolish to ever try because of the decades of manual optimization that I've already mentioned. So GCC is super duper ultra fast, and we just generate C++ code that can utilize that. Now, of course, the trick is to get Perl to compile into C++, and if it were easy, then everyone would be doing it, but it's not easy enough that only I, in the whole world ever, have done it with the RPerl optimizing compiler. So you're welcome, everyone. RPerl is by no means complete, but we are on version 5.2 if I remember correctly at this time, and we do release a major version every year on the Independence Day of this great nation. No, I don't mean Texas, I mean the United States of America. So on the 4th of July this year, we will be releasing RPerl 6.0 and so forth. Each new version of RPerl has all new features and all of the cool stuff that really cool programmers want to access. Now, you may have had difficulties getting RPerl installed and so forth. Believe me, it's not easy to get RPerl running because it requires a lot of different software components to work together, including the C++ compiler and several other things. This is why we built the RPerl Docker container, so that you can just type in one little RPerl Docker run sort of thing, and it will download off of Docker Hub and run everything pre-configured, and you'll have your own version of RPerl working with no effort. You can get all of that details on the rperl.org website and just click the button that says Get RPerl, and it will show you the commands and so forth. Now, let's talk about the speed of RPerl. Obviously, generating C++ is going to make this extremely fast, but it's not just about one type of speed or the other. So basically, you have two different modes of execution for any software in the world, whether it be system software or application software. And the most generic that I can get are these two modes of serial, one thing at a time, and parallel, a whole bunch of stuff all at once. Now, which would you prefer? Serial, one thing at a time, or parallel, a whole bunch of things at once? Obviously, parallel is better. So, essentially what you end up with is two different types of computing systems. Now, there's serial hardware and there's parallel hardware. There's also serial software and parallel software. And within each of those, there's hundreds of different categories and classifications and considerations. We're being very generic today. So if you have a normal piece of software that's running on your computer or your cell phone or your server, whatever, this is what we call serial software. It means that it's only running one thing at a time. That means it adds these two numbers, and when it's done, it can add the next two numbers, and then when it's done, it can do the next thing, and so forth. It has to wait for each operation to finish before it moves on to the next operation. And this is the way that computers have always worked as far as software is concerned, because it's very difficult to write software that will run things all at once. It's hard to understand software that tries to run things all at once. It's very difficult and expensive. And that's called manual parallelization, when you have a human programmer that's writing software code which is parallelized and can run many things at once. But that's very rare, and it can only happen in big companies or major educational institutions that have big budgets and or underpaid graduate students who can do a whole bunch of work in order to make that happen. it could be 10 times or 100 times more difficult than writing the same software in serial. So pretty much all your software that you use nowadays is written in serial. So when we talk about RPerl, the optimizing compiler, in serial, what we mean is just taking a normal Perl program, a normal Perl application, and running it through RPerl and taking the C++ code as it is. And it runs one thing at a time, one thing at a time. Now, the speed that we achieve by doing that is essentially equal to the speed of C++ because we're generating C++. It is C++ that's getting compiled and run. So the serial speed of RPerl is essentially equal to C or C++ or Fortran, because remember, they all three use the same compiler. That puts Perl right up with those three languages. Now, what happens if you try and run normal Perl, which is an interpreted language instead of compiled with RPerl? Normal Perl, which you can see is a camel, although there are camel races, camels are not known as speedy animals like a roadrunner. So the camel is an apt analogy, perhaps, and unfortunately, if you do any timing or research at all, you will find that normal interpreted Perl is woefully slow. In fact, it is essentially at the bottom of the speed list, which you can look up if you Google Alioth Shootout Benchmark Game. That's A-L-I-O-T-H, Alioth. There's all the major languages compared together. Now, that website is far from intuitive to utilize, but the data is on there. If you click enough buttons and menus, you will eventually find it. And you can compare Perl to all these other languages using a number of different common benchmark algorithms. So what we find is that Perl is hundreds of times too slow in many cases compared to C or C++ or Fortran, which are always at the top of the list. You'll also find that we are dozens of times too slow when compared to Python or Java or JavaScript or the other popular languages. And all the other hundreds of languages are just kind of spread out in between. But Perl really is at the bottom of that speed list, and if you don't like what I'm saying, I mean, you can deny the reality, but there's a reason why I had to write the RPerl optimizing compiler. It's because normal old slow Perl is pretty dang slow. In fact, it is so slow that it is impossible to utilize normal interpreted Perl for scientific calculations in a reasonable manner. If you want your stuff to run for years and years, something you could do with Python in a few days or weeks, then okay, but why? It would be crazy to do so. It would be foolish, it would be silly, it would be illogical, as a certain Vulcan science officer might say. So you have to use RPerl if you want to get reasonable performance out of Perl. If you don't want reasonable performance, okay, fine. Now, what about the parallel speed. If the serial speed of interpreted Perl is super low, and the serial speed of compiled Perl is super high, what about parallel? Well, we have to first talk about parallelism just for a moment. What we find is that, as mentioned, writing parallel code is prohibitively difficult and expensive. And only the smartest of programmers, the cream of the crop, the most highly paid, sought after, hard to hire and find software engineers can truly master the art of parallel programming. Believe me, I've tried. So, where does that leave us? Well, it means that in the past, only those big institutions with big bucks could do it. Or just somebody who's really super dedicated and spends all their time with no pay for a long time to do it. But that's not what we want, obviously. That's far from ideal. What we want is to have help from the computer. And it is definitely possible to achieve this. I would like to give a shout out. I would like to give proper respect and admiration and credit and kudos to the many different groups worldwide who have been working on this problem, including my friends at Texas Tech and from school there, including myself, including those who have worked on other parallel systems, and especially the Pluto development group, which is a polytope loop parallelization library. So let's go over that for just a second. Pluto is the name of the software, like the planetoid or the Greco-Roman deity or the cute dog off of the old cartoons that we used to watch. Pluto is a system that you give it for C code, and it will analyze the loop structures, and it will transform those loop structures in some way so as to allow them to run in parallel if possible. And this is a relatively complicated procedure that requires a type of math, a type of computer science that is called polytope. And this is, it's kind of like a polyhedron. It's a multi-dimensional grouping of data points within a time matrix of some sort. And it allows the analysis of the data dependencies and the computational dependencies between these points in time within your loop operations. And by making this multidimensional analysis, the Pluto software can transform a loop from a serial execution mechanism or construct into a parallel construct. And I have incorporated the work of the Pluto team and their open source software into the open source RPerl compiler, so that when you compile a Perl loop, it will run that loop through Pluto. Well, first it will compile it into C++, then it will run that C++ loop through Pluto, and then it will link the possibly modified C++ code back into your compiled Perl program. And at that point, it will also it will also activate another system that's called OpenMP, which is a parallel computing platform. And usually OpenMP is used for manual parallelization, but in this case it's part of an auto parallelization. And this is in fact one of the most important features and underutilized features of the RPerl optimizing compiler, is to be able to write parallel software, auto parallelized software. You can go to autoparallel.com if you want to hire our Perl software company to parallelize your software for you. And we, of course, use the RPerl optimizing compiler to achieve this. Now, I won't spend much more time talking about RPerl because I know that we need to breeze through a couple other important topics here in the next 20 minutes. I will say that RPerl is one of, if not the most important part of the entire Perl community roadmap. This is something that I cannot emphasize enough, because without the ability to compile our code, we can't build the apps that we need for the future of Perl. We can't have the machine learning that we need to compete against Python, which is just destroying us for corporate jobs and money. We can't build the super high-tech scientific things that we need to solve the grand challenges and help humanity and help save the world. And we cannot live up to our legacy status because all of the other legacy languages are running at an ultra-high speed. And rightfully so, because they're so critically important to the infrastructure of the future of humanity, both on this planet and beyond, that they have to run fast. They have to run as fast as possible. And Perl has to now live up to that benchmark as well. We're way down here on the benchmark list, below the bottom of the video screen, and we need to be at the top. We need to be above the top. And what do I mean when I say that? Because that's kind of the big thing that I'm leading up to with RPerl, is that when you have automatic parallelization, which we have in RPerl, and you have the serial speed that's equal to the existing fastest languages of C and C++ and Fortran, what you have now created, what we have now created, what I have now created is the fastest language and compiler in the world. And this is an open challenge to any language developer, any software programmer, any Perl haters out there who ever believe that their software can be faster than ours. I will personally compete against you. This is an open, permanent challenge to the world for at least the next 300 years. After that, we may end up upgrading to Raku. But until then, you can't beat RPerl. And you know what? If someone comes up with a new idea of how to make a compiler run even faster, we'll release in the next major RPerl version on the 4th of July, baby. So, that's quite a bit about RPerl. Let's see. Okay, we have one more question, I'm sorry, about RPerl. Tommy Butler says, what extra code do you need to leverage parallelism? That's a very good question, Mr. Butler. And it's an important question, and the answer is essentially none. The only thing that I personally put into RPerl to make it easier for annotating the code is that you add a loop label that has the word parallel in it. And it can be just the word parallel, or it can be foobar parallel, or my parallel donkey, or whatever you want it to say. But all that means is that instead of writing for blah, blah, blah to create the header of your loop, you write parallel : for blah, 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 and then you write your loop. So it's just a few extra characters that you type at the beginning of the loop. And honestly, when the world finally makes the change to only parallel software in the coming decades, then we'll just enable it by default and it will always be turned on. And then at that point, you won't have to even type the word parallel. So I went ahead and gave just a tiny little code annotation so that it's easier for us application programmers to remember which of our loops we want to be parallel and which ones we don't care about. Because you don't want to have to run Pluto over and over and over again for no reason. So it saves you a bit of time during the compile phase to only parallelize the loops that you know you want to run fast. So thank you, Tommy. Yes, it's mind equals blown. Yes, I see your little atomic bomb brain blowing open icon there. And again, that's why the name of our Perl services company is Parallel Technologies Incorporated. All right, if you're not using RPerl yet, time to upgrade. Now, let's move on to the next Perl, CPerl. And I'd like to go ahead and start with another shout out to Rainy Urban, my longtime friend and brilliant programmer from Austria, and his wife Miriam. Hello, y'all, probably overseas somewhere at the film festivals or whatever you're doing here in the quarantine, the virtual Cannes festivals, I don't know. Rainy is a famous surfer and chess genius. He's had some movies made about him. And he's also the current maintainer of the Perl Bytecode compiler, which you can use for interpreted code. We'll talk about that in a minute. And he's also the creator of the CPerl fork of Perl. So Rainy is probably the only person smart enough, brave enough, and dumb enough all at once to actually fork Perl itself. That means the actual C89 code is forked. And I don't just mean like to make a fork on GitHub so you can, fiddle with the make files. I mean that Rainy is changing the Perl internals. And again, this is maybe the most complex language internals on Earth. Which again means that only the most super smartest of programmers in the whole world can even think of working on that. And yes, Sawyer X, you can take that as a compliment if you ever bow yourself down to the level of watching my humble Perl Town Hall videos. And all you other Perl 5 pumpkins who following in the steps of our great Saint Larry, actually had to touch those Perl internals. It's crazy, as past pumpkin MST Matthew S. Trout once described it to me. It's like an old, rusted out, broken down pickup truck that a bunch of guys are standing 50 feet away shooting it with paintball guns in an attempt to make it look nicer. And essentially what that means is that the Perl internals are the pickup truck, which is kind of too old to try and change in any major way. And the best that we can do is some cosmetic changes like adding syntax sugar or little features that are really just rehashes of existing features in a more convenient way, which again often amounts to syntax sugar or just making it so that you have to type a few less characters, which those of you who are familiar with the low magic Perl commandments as part of the RPerl family of software and documentation, you will know that we do not allow or condone, thou shalt not use time-saving or character-saving tricks, because in the end it will lead to code that runs slower, has more bugs, and is less understandable and maintainable. So we want low magic code that anyone can read and understand, and that explicitly names out all variables and data types and so forth. This is the code that will stand the test of time. This is the code that will run faster than anything else in the world. This is the code that will still be around in 300 years. So please, use low magic code when you can. If you really, really are just addicted to high magic features in Perl, start weaning yourself off of it. Start writing a few functions here and there, a few subroutines here and there, which use low magic instead of high magic, and you'll thank yourself. And you can give yourself a gold star and a pat on the back every time you do, and you can talk to me about it, and I will coach you through it, and I will give you a virtual high five. So back to Rainey. Rainey forked the entire Perl interpreter. He's made some major changes to the internals. From what I understand, he's got 100 or 200 patches that he is curating and applying to the Perl interpreter that give you a lot of potential benefits. So one of the biggest features, probably the most important central feature that you are going to receive with the CPerl interpreter, is the ability to compile your code into bytecode. Now, this is different than compiling your code into optimized C++, which is going to end up as binary code. Bytecode is a form of intermediate code, and really Perl has a type of bytecode which is actually an operation tree, an op tree we call it, and there may be some subtle differences internally between what Perl calls bytecode and what Perl calls op tree code, but for the sake of this discussion, we'll consider them to be the same thing. And the operation tree is what the Perl run loop executes. That is essentially the Perl interpreter. It's written in C, as I mentioned, and it just has a loop that runs over and over again until it does all the operations in the op tree. And that is a dynamic data structure that can be changed because Perl, it can change during runtime because Perl is a dynamic language. So it may need to change some of the data types and so forth. It may need to do runtime code evaluation using the eval operation or other things that are considered to be dynamic behavior. So what you can do with CPerl is you can actually use the BCC command. The BC compiler and the BCC compiler systems, it's using the Perl CC command for BC and BCC. What this allows you to do is to dump out your op tree either into bytecode or into actual C operations, and then save that bytecode or compile that C code and run your Perl that way. Now you may be saying, why would I want to do this? And there's the one main answer is startup time. Speed of startup. How long does it take from when I hit enter to when my code is actually running? And with gigantic Perl code bases that are grabbing tons of distributions off of CPAN and loading hundreds or thousands of modules, that startup time can be over 1 second, or it could even be several seconds long. And that's no good. That's, cost prohibitive when you need to run server code, because you may have hundreds or thousands of users that want to run that code. And if each user takes several seconds to run, then all of a sudden your server is locked down and it's not providing the services. So one of the biggest use cases for this was the cPanel proprietary Perl software that is used on most servers on the internet today. And this is created by the eponymous company cPanel in Houston, Texas. I salute the state of Texas, here our home state of RPerl, although Austin Perlmongers rule. But in cPanel, when Rainey used to work there, they needed to have the Perl C or bytecode compiler for startup time. And this allowed them to compile their program, which is a server-side program, to start faster, to have an immediate response time, and also it allowed them to protect their intellectual property. In other words, hide their Perl source code. So if you really, really need to hide your Perl source code, you can kind of sort of do that using the BC compiler system. And again, it's not optimizing for runtime really, but it's optimizing for startup time. Now, since I say that, I will briefly mention that there is a bit of runtime optimization. I've heard Rainey tell me that he's gotten upwards of a 20% speed up. So that's you know, a 0.2x speed increase. So you would be running at 1.2x instead of a 1x speed. 1x is the normal Perl interpreter. And I should go ahead and mention, since I neglected foolishly to do so, that with RPerl, while there are several run modes within RPerl itself, just running in the normal C++ serial run mode, we have seen upwards of 400x. That is 40,000 times, 40,000%, 400 times 40,000% runtime of the normal Perl interpreter. Got to get my mental calculations right there. So yes, you can get some speed increase for CPerl in your high magic Perl code, but that's not really the main point. The main point is startup speed. And I should also make an important distinction that CPerl is for high magic Perl code. That's dynamic, it could use eval, it doesn't need to have data types, and you can use all the weird wacky special symbols and Perl magic that you want. You can make your code unintelligible to any other human being if you really want to, and it will run through CPerl in theory in the same way that it would run through normal Perl interpreter. This is because CPerl is a fork of normal Perl. Now, there are some subtle differences that you would need to read the CPerl documentation, so you may have to tweak your Perl code, but the idea of CPerl is to be as close as possible to compatible with normal Perl, and with just the benefit of the boost of startup time. So you can go ahead and contact Rainey if you want more information about that. He does have a CPerl website under the perl11.org umbrella, and you can get all kinds of information about that. We do have a few comments from Mr. Mokapati here. Is there a tutorial on RPerl? I tried installing CPerl using Perl Brew on RPi and it crashed the little puppy. We'll try again. But was anyone successful with RPi? I assume that's a hardware device like the Pi hardware devices. I have not used CPerl on that. You would need to ask Rainey directly. As far as the tutorial for RPerl, if you look at the Meta CPAN for RPerl, there is a basic documentation there, and if you go to RPerl.org, there is the Learning RPerl ebook, and I will mention that they are both in need of an update, the documentation, both the Meta CPAN pod and the Learning RPerl ebook. And I will also mention that we have that high on our to-do list. I'm actually in the process of a major upgrade to RPerl at this time. Hopefully we will have done for our next major release on the 4th of July. And when that is done, then we will upgrade all of the documentation and create some new tutorials and so forth. At that time, we will be creating video tutorials, written documentation updates, all of the things that RPerl needs to be easier for you to understand and get a quick start on. So please keep supporting RPerl. Keep pointing yourself to our Patreon, and you will see updates in the coming weeks and months. So we've hit our 1 hour mark, but I am gonna skim through the next couple sections a little bit more quickly here. Big data, if you don't know what it is, it's a buzzword. It's basically when you have data sets that are too big to analyze traditionally, and there's a lot of really amazing stuff that can come out of big data. You can find trends and correlations and patterns that you never knew about before. The applications are almost endless. I mean, you can, from medical to consumer, industrial, machine learning, pretty much big data can impact everything. It's just a matter of having a software system that's fast enough to process it. So we once again come back to, you guessed it, the RPerl optimizing compiler. If you don't have RPerl code, if you don't have super fast serial, if you don't have automatic parallel, you don't have big data analysis. You've got to have those things to be able to process, you know, gigabytes, terabytes, exabytes, yottabytes of data. These are gigantic, enormous, super crazy, huge amounts of data. And we've got to have parallel software that can run faster than anything else. So RPerl, once again, a central component of Perl ever being able to compete in the big data sector. Obviously, Perl has lots of features for databases and so forth. We've got, you know, initial MongoDB and Postgres support even with RPerl, but we're still a ways away from being able to compete directly against the big players of C or Python or even Java in this space. But we need to focus and push forward and get Perl running faster and faster and faster so that we can get into the big data market. So we're just going to touch on that very briefly. Move on to multi-core computers. Every computer and every laptop and desktop for over a decade, nearly 2 decades, has had multi-core chips in them. This basically means that your CPU or your central processing unit can perform more than one calculation at a time, like we were talking about before. This means that you already have parallel hardware, but it's not really being utilized. You can do trivial parallelization by simply running multiple applications at the same time, but each application is only using one core, pretty much, at a time. So in order to have a single application that's using a whole bunch of cores, that's where you have to have the parallelization. That's where you really need to have the auto-parallelization. And you guessed it, we're right back to RPerl. You gotta have RPerl. If you don't have RPerl, you're not going to be running Perl on a multi-core chip. I'm just going to throw that right in your face. You're going to have RPerl. So there's all kinds of consumer things that you can do with consumer-grade parallel chips like this. You can do faster video games. You could do, you know, video editing. You could run your own personal servers. The list goes on. You can read the Perl Community Roadmap if you want more information. But everybody already has multi-core. You've already got parallel hardware right in front of you right now, probably. Even on a lot of cell phones, you've got multi-core cell phones. Why not? We need to be able to compile Perl onto those multi-core chips. that's a big deal. Hello, Robert. Thank you for joining us a bit late. You'll probably want to rewind and watch from the beginning. Moving on, supercomputers. This is the industrial strength parallel hardware. Basically, instead of 2, 4, 8, 16 cores, you're talking about 256 cores, 1,024, a ton of cores. Sorry, somebody is sending me a message. I need to mute that. Okay. So, hopefully you can all still hear me. If someone wants to give me a yes, we can still hear you comment, that would be great. But yes, basically what we're looking at is supercomputers are thousands of cores nowadays. They probably have ones that are over 1 million cores. And in order to scale up to that, what are you going to need once again? Automatic parallelization. You're going to need RPerl. So we just keep coming back to RPerl, keep coming back to RPerl. I didn't make this up. I did invent RPerl, but I did not invent parallel hardware. I did not invent the need for parallel software. I did not invent Perl itself. I'm just putting it all together for you, our beloved Perl citizens. So, supercomputers, the stuff that they do is crazy. Solving scientific challenges, grand challenges, curing cancer, making Hollywood movies, big data like we just mentioned, all of these things that are gigantic beyond the scope of any other computers, they have to go on to supercomputers. And I grew up working on supercomputers as a teenager, working in the Texas Tech University High Performance Computing Center. Hello to all of my old friends from the HPCC. And yeah, I mean, this is what got me started as a boy. So supercomputers, got to have RPerl. And last but not least, we have our speed competition events. This is going as fast as you can, running your code as fast as you can to compete against other programmers to see who will be the king and queen, who will wear the crown, who will win the awards, the trophies, and the bragging rights as having the fastest software in the world, at least for that event. And it's essentially, a similar pattern to hackathons and install fests, which we've already talked about. These are supposed to be fun events. They're supposed to be community-driven events. And they're supposed to bring people together to focus on making some progress, doing something cool, running some Perl code, maybe writing some new Perl code that runs faster than the existing Perl code. Whatever it is, it's going to be something fast because that's the whole point of the speed competition. So basically, you're going to set up an event that has some rules, it has some food and drink, it has some nice place to meet, and you're gonna find out who can write the fastest code to do some algorithms that you determine in some way. I don't know exactly what your rules would be regarding that. But you would make up your own rules if you need to, and try and make it fun for everyone. So basically, what we're thinking is that everybody would probably have one per year, so it's an annual event, and each major city, like Austin or Sydney or Paris or wherever, you would have one big speed event per year, one big speed contest, and so that would determine who is fastest in your city. And then every 3 or 4 or 5 years, we can take all of those fastest people and have an international championship. So your local tournaments can feed into this broader championship and find out who is the fastest in the world. So we can compete different languages. It doesn't just have to be Perl. You can have different brackets, maybe the Python bracket and the Java bracket and the Perl bracket, and then at the end you combine them all together, or compare and contrast them. Or maybe you have the video game bracket and the scientific code bracket, or however you want to come up with your own ideas. This is something that it's an evolving process that we're all going to work together in time to figure out how to make it a fun, engaging thing for the community. So that is the speed competition event, and we should be showcasing high-performance Perl code. We should be showcasing RPerl. We should be showcasing CPerl, compiling some bytecode or something like that. And in the end, the idea is just always to try and bring more positive enthusiasm to Perl. Bring more positive exposure, media exposure, blogs, videos, all the things that we need to promote Perl and to make Perl a success and to make you all successful as Perl programmers, to make us all financially stable and secure with our futures as Perl programmers, and to make the world a better place than how we found it. And that's the idea that we get from St. Larry, our founder, and that's the idea that I give to you as your fearless leader, Will the Chill. So that's the end of our Perl Town Hall meeting for today. This was the performance segment, and we covered many different considerations in relation to the performance of Perl. So I thank you all for joining us. This was the Perl Town Hall, broadcasting live from sunny and beautiful Austin, Texas, the home of the Austin Perlmongers and the headquarters of the RPerl Optimizing Compiler. Thank you all. This is Will the Chill signing off. Until next week. And